This is number 3 on the blue worksheet. So very similar to number 2, we have a ball that's thrown vertically upward. It doesn't specify if it has any horizontal component or an angle, so we can assume totally vertical. So based on this, again, it's not a true projectile, but it does have the projectile symmetry. So V initial y is 14 meters per second. The velocity that it experiences at the peak is going to be 0. So that means we are going to have a delta y peak, which is the height to get to the peak, time up, which is time to get there, time down, which is time to fall back down to the hand, and then a gravity value of 0.981 meters per second squared. We also are going to have a v final in the y direction, which is going to be negative 14 meters per second because of the symmetry. So the velocity that we start with is the same as the velocity that we end with. And then due to the symmetry, the time up that we have is going to be equal to the time down. So we're asked to find the maximum height, how long it takes to reach the peak, and how long does it take to get back to hands. So as far as different things go, I'm going to find how long it takes to reach the peak first. I'm going to use v final y is v initial y plus gravity times time. So that's 0 is equal to 14 plus negative 9.81 times time. So solving for the time, I'm going to get my time up value, which is how long it takes to reach the peak, of 1.43 seconds. So that answers question B. Now we could have potentially done the maximum height section first if you want to, because there are equations that do not need time, but we do have options. So doing that, I'm going to do v final y squared is v initial y squared plus 2g delta y. So I could have done 1 or 2 first, it doesn't matter. So 0 squared is equal to 14 squared plus 2 times 9.81 times delta y. And it's important to keep the direction. So the VOY is positive because it was directed upwards. The gravity is negative because it pulls down. So that's going to impact your answer. So make sure you keep the right signs. So I'm going to get a delta y, which ends up being 9.99 meters. So that's the answer to A. And then, like I said, the previous thing that we did was the answer to B. Now, how long does it take to reach the hands that it left? Now, the symmetry of these projectile-esque problems is that up and down are equivalent. So once you find the time in one direction, it's just double. And I write it as time x here because that's how we refer to it when we use projectiles, because it moves side to side. In this situation, we aren't experiencing any lateral motion, but I still kept it as time x so that you get used to the notation when we do the projectiles. So the total time is just up plus down, or 2 times time up. So we get a time of 2.86 seconds. And that's the time that it is spending while in the air.